Hello everyone, welcome back to another episode in my Unity Open World series. So in this episode I am going to work on the eye case for the character. So that means I am going to make this character place his foot properly on when he is on a slanted ground. In a slope he will place his foot properly on the ground like this. So that's what I am going to cover in this episode. And this episode is sponsored by these generous patrons. Thank you very much for the support you are giving me. So you are my first patron. Alright, so first of all I'll give you a brief introduction on what I am going to do. So actually here when I was in this slope area, as you can see my legs, my foot is not on the ground, the left foot is in air. So that's what I want to fix with IK. So actually what I want to do is move this left foot downwards and keep this, so both foot will be on the floor properly like a real human. Okay, so first step is I have to open the animator, and here I have to enable IK pass. When active, the layer will have an IK pass evaluated. It will trigger an on animator IK callback. Yeah, so that means if I enable this, on animator IK callback function will be called. Okay, so test that now that I have enabled IK, and in this character animation event, so that's not the, I don't want to put IK functions there because they are not events. So let's create a separate script for that, because put in the on animator IK function in this character animation controller script will be no use, because that animation controller object is not attached to the character mesh which has the animator. Okay, so let's create a C# object, C# script. Let's call it character IK, and I'll open it. I'll add this dependency, require component animator, because we need an animator to work. And now I'll just add void on animator IK. Okay, so let's just add a debug line, and I'll use call on animator IK just to see if this function is being called, because I want to test that first. I'll add character IK script here. Yeah, as you can see this function is being called. Alright, so let's proceed now. So okay, so to work with IK I need to know the structure of this avatar. So we have left arm, body, right arm. Okay, and that's just for reference. All right, how to close this? I don't need to change anything, I just wanted to have a look. And then right. Okay, now how to get started? First I need a reference to the IK, sorry, to the animator, not IK. So for that I'll create protected animator, sorry, animator. And in the start I'll initialize it, animator equals a component animator. So it will filter out and get the animator component of this object. And here well, just to test, I'll add a function like this: animator set IK position, avatar IK goal, left foot, and the position should be left new vector 3. How to access the current position? Let me try this. No, I can't do it like that. Maybe animator get board transform. Okay. And how do I define the one ID? Bone. Will this work? I'm not sure. Let's try. So what I am going to do is, okay, let me make it simple for you. I'll add a vector 3 left foot. That's not clear. P left foot equals this. So I store so in this P left foot variable I store the left foot location of the body. So then in here P left foot get X and P left foot get Y minus 0.2 f, and we left z. So actually what I'm trying to do is I'm not sure will that work or not. So get the current position of the P left foot and move it down. So this can have a recursion effect, but at this point all I want to know is that if this has some effect on the character. So let's see what happens. Well, nothing is happening. Let's print this P left foot value. And I'll keep it this size. Okay, it seems I'm getting a value, and I think I have to set the IK weight. Yeah, animator set IK position weight out IK goal left foot, and value I'll set it to 0.6 f, because I don't know, I am a little bit afraid to make it 1, thinking something might go wrong. Okay, now as you can see, right, it is somewhat, this has some effect. Why doesn't it stop? Okay, let's stop it here. Right, it is moved downward a little bit, the left leg. So now we need to know the exact amount that we need to move the leg down, but only moving the leg is not enough. We have to move the entire character hip as well. Okay, so to identify the exact location that we need to move down, we have to do a line cast. Right, let's create another function, vector3, it should be private, get hit point, and the input should be vector3 start and vector3 end. So here I'll add a recast hit object. Now I'll just call it hit. So this is used to store data if we get a hit from a line cast. So physics line cast, the start is start, end is end, and then we don't need a layer mask. What else? Right, out hit, Okay, so this should be inside an if function. If this is true, that means this hit object will have more information about the hit location. So I'll return hit dot point impact point in world space. This is what it contains, and otherwise return end. So it will just return the end point. Okay. Oh. Right. Now I know the left foot location, and I need to know the right foot location as well. Or can I just use a single object here? Yeah, I'll rename this to foot location. Wait, what happened? Okay, now all I have to do is here at first, no, I'm gonna need two objects. Sorry, I'll name it L foot, and I'll create another function, another line like this, same for R foot, which stores the location of the right foot, and this should be right foot. I'll print this one. No, I don't think I have to print it now. Then what I have to do is L foot equals what's the method name? Get hit point. Get hit point. So the starting position would be L foot plus vector 3 dot up. So that means some point above the left foot, and the end position should be L foot plus minus vector 3 dot up multiplied by maybe 5. So here like this I will get the left foot location, and then similarly I need to get the right foot location as well. So R foot okay. Now here for the left foot, instead of this new vector, I'll just give L foot, and similarly I'll do the same for the right foot as well, like this. Right foot okay. Now let's see what happens. Let's maximize the view. Okay, we have some effect, but it's not perfect yet. Wait, let's try what happens if I make this weight instead of 0.6. I'll make it 1. Okay, now it is touching the ground. What else? But it's not perfect, as you can see, because we are only moving the foot. We need to move the hips as well. So that's why this looks like a robot. Also, I think we need to add some offset because foot location is should be a little above the ground. It should not be submerged. Like this. Okay, to fix that, let's add an offset like this. L foot, let's set it like this, and then let's add another, I'll define another variable here, public not float vector 3 foot ik offset, and I'll add that to this, no, not here, at here. Wait, for ik offset. So I'll disable maximizing and play. Okay, now I'll select the character mesh, and I'll give some value here. 5. Oh, 1 is too much, definitely. 0.1. Is that good? Let's go to the scene so we can clearly see that. Point 1 2, no, 0.12, 0.13, 0.15. Okay, that's good. So that's the value, 0.15. Alright, so now this foot is okay, but the left foot is not okay. That's because I think it has stretched the most amount it can stretch, but it can't stretch further down because otherwise this leg will deform. So to fix that, what I have to do is moving the hip, moving the entire body down. Okay, so far we got this, but as you can see here, this foot is not placed properly on the ground. So to fix that, what I have to do is moving this entire body down. So if I do it manually, it would be like this. So that's what I am going to do today, moving the body manually to place it properly on the ground. So right, how do I do that? Well, actually it's not that complicated, I guess. So I already know the left foot location and the right foot location. So if I take the difference of these two and then divide it by 2 and then add that difference, subtract that difference from the and add it to the actual location of the mesh and move it down a little bit, I should get it in the proper place. So yeah, let's see how to do that. So yeah, actually it's like this. Here, transform to local position. So at the moment the local position of this object is 0. This character mesh is 0. So I need to move it down a little bit. So equals new vector 3, x is 0, I don't have to change anything there, and z also should be 0 because I'm not going to move any z direction also. So for the y part, let's take L foot. No, let's math dot absolute value L foot minus R foot and divide it by 2. So here we only need the y component. I think that's all I have to do. Let's see. No, not quite. Right. Okay then. Right, so this is plus, it should be minus, right? Yeah, it should be minus because yeah, right. So now you can see the leg is properly placed on the ground, no matter which direction the character is facing. And we need to enable and disable this effect based on the character's movement speed, because so by doing that we can get rid of this odd working style this character has. So he's like dragging on the ground, that's not good. Okay, so yeah, that's all for this episode. I thought it would take longer than this, so that's why I wanted to do this part in a separate episode. But anyway, we are done for the day. And if you like to support my work, you can get the membership of my Patreon club. Link could be in the description below. And based on the tier you join, you will have different privileges.